Hello everyone. All right, so today we're going to do a graphing polynomials worksheet. I am going to do one for you and you are going to have a different one to do as an assignment. All right, so let's look at properties of polynomial functions, worksheet number 2. All right, so here we have our function, which is right here. Okay, so it says, what is the degree of the polynomial? Now, to find the degree, it means the highest degree. Okay, that's our highest degree. So this is a 4th degree polynomial. Our leading coefficient, okay, it is positive 2. And what is our constant? Our constant is positive 15. Okay, our constant is the number here without a variable. Okay, so now we're going to go over what the possible rational roots are, which is p over q. All right, our p here is our constant, which is 15. And our q is our leading coefficient. Okay, so we're going to list the factors that make 15. So I know 1 times 15, 3 times 5, and those are all our factors that give us 15. Okay, and on the bottom we have our p, or sorry, our q, which is 2, and what factors do we multiply to give us a 2, which is 1 times 2. All right, next we are going to do we're going to list all the possible rational roots. Okay, so first it's 1 divided by 1, which is just 1. Next it's 1 divided by 2, which is plus or minus a half. Okay, now we're going to move on to the next number, which is 3. We're going to do 3 divided by 1, which is just 3. 3 divided by 2, which is 3 over 2. Okay, let's move on to the next one. 5 divided by 1. Okay, 5 divided by 2. And lastly, we're going to go to the next one, which is positive 15 divided by 1. Positive 15, or plus or minus 15 divided by 2. Excuse me. Okay, so those are all the possible rational roots. Okay, now we're going to find the x-intercept. Now to find the x-intercept, we are going to substitute x is equal to 0 into the function. So the function up here. We're always going to go back to this function. All right, so let's plug in x equals 0 to find out what our or y-intercept is going to be. So by substitution, 2 times 0 to the 4th minus 0 cubed minus 17 0 squared plus 0 plus 15. Okay. All right, so here anything times 0 is 0. Okay, that means when to find f of 0, it's going to give us 15. So that is our y-intercept. In other words, when x is 0, y is 15. I can do it as an ordered pair. All right, next we are going to find f of negative x. Now we're going to use the original function up here. All right, and we're going to plug in, instead of x, wherever we see an x, we're going to substitute negative x. Negative x to the 3rd minus 17 negative x squared plus a negative x plus a 15. Okay. So anytime we have a positive, or I'm sorry, an even power, it's going to give us a positive x. Okay, so this just turns out to be 2x to the 4th. Negative times a negative is a positive. Okay, this is because it's an even power, it's going to be a positive. So positive times a negative is a negative. Okay, positive and a negative is a negative, and plus 15. So this is our f of negative x. Okay, now we're going to use these two to use our Descartes rule of signs. So there was a reason why we did this. So this is our original function. Okay, and our f of negative x. All right, and we're gonna fill in the chart. So this should look familiar because we did this as a homework assignment. Okay, we're gonna find where our signs change. So here it went from positive to negative, that's a sign change. Negative to negative, not a sign change. Negative to positive, yep, the sign changed. Positive to positive, no, it didn't. So here we would have two positive real zeros. Now let's check our negative real zeros. Okay, so we're looking for sign changes. Positive to positive, no. Positive to negative, yes. Negative to negative, no. Negative to positive, yes. So this also has two negative real zeros. All right, and we know that we have to have 4 roots. We already have 2, so that means this has to be a 0 because 2 plus 2 is 4. All right, next I'm going to come up with other possible solutions. So maybe I have 2 positive zeros. Remember, these can go down by 2. These go up by 2, okay? So that means if I have maybe 0 negative real zeros, that means I would have 2 complex. Okay, what if I had 0 positive real zeros and 2 negative real zeros? That means I would have 2 complex, and another combination would be, what if I had 0 of these 2? That means all 4 of my roots would be complex. All right, so now we're going to use the remainder theorem to evaluate. Okay, so it's like plugging this into this function. Okay, negative 2, but I'm going to use the synthetic division, and I'm going to use the coefficients. So 2, negative 1, negative 17, 1, and 15. Okay, so those are my coefficients that I'm going to use for 2, negative 1, negative 17, positive 1, and 15. All right, so let's do the synthetic division to evaluate. Bring down the 2. Then I do 2 times negative 2, negative 4. I add, this is negative 5. Then I do negative 5 times negative 2, 10. I add negative 7. Negative 7 times negative 2, 14. 14 plus 1 is 15. 15 times negative 2 is negative 30. So here I have a negative 15. All right, so that tells me that when I have f of negative 2, it's going to be equal to negative 15, or I can write it as an ordered pair. All right, I'm going to do it one more time, but this time I'm going to use a 2. So same coefficients, 2, negative 1, negative 17, 1, and 15. Okay, same thing, bring down the 2. 2 times 2 is 4. Negative 1 and 4 is 3. 3 times 2 is 6. I add, this is negative 11. Negative 11 times 2 is negative 22. This is negative 21. Negative 21 times 2 is negative 42. And then I add, which gives me negative 27. So this also means that when I evaluate my function at 2, it should give me negative 27. So I can write this as an ordered pair. All right, so next, number 7 says to, or asks me to apply the remainder theorem to all possible rational roots of the polynomial function. Now it says to all. I'm not going to do them to all. I'm going to pick the ones that I like and see if I get any zeros. Okay, so I'm going to start with, let's see, what are my possible rational roots? These are the numbers I can choose from. So the numbers I'm actually going to choose are my favorite number, 3 and 1. Everybody knows me, I love the number 0, but 0 is not a choice here. It wouldn't be a rational root. So here, I'm going to do synthetic division with the function. Okay, so I'm going to use these same coefficients to do synthetic division. So I'm picking, I want to pick 3. I'm going to pick 3 and I'm going to pick number 1. It could be positive or negative, whatever. I'm just going to pick positives. All right, so I'm going to do synthetic division. So remember, I'm using this polynomial. So I'm using these coefficients. All right, so to do synthetic division, 2, -1, -17, 1, and 15. All right, synthetic division. Let's see if we get a 0. Bring down the 2. 2 times 3 is 6. 6 and -1 give me 5. 5 times 3 is 15. -17 plus 15 is -2. -2 times 3 gives me -6. -6 plus 1 is -5. -5 times 3 is -15. When I add 15 and a -15, it gives me 0. Yay! You know what that tells me? This is a root. Yay, I found one. So x equals 3 is a root. All right, so now I can rewrite this. Remember, we started with a 4th degree polynomial. If we factor out a root or get out a root, take out a root, that means now it goes down by 1. So I no longer have x to the 4th. This is going to be x to the 3rd plus 5x squared minus 2x. Okay, so that's my new polynomial. So now I'm going to try, so I know that this was a root, so I'm going to try 1. So I'm going to do synthetic division, but now I'm using these coefficients, okay? All right, so let's find out. Let's do division, synthetic division. Bring down the 2. 2 times 1 is 2. This is 7 when you add them. 7 times 1 is 7. This is 5 when you add these two. 5 times 1 is positive 5, and it gives me 0. Yay! That means this is a root. Okay, if it's not a 0, it is not a root. So you have to use a different number until you get a 0. So that means x equals 1 is a root. Yay! All right, so we had this polynomial was a to the 3rd power, right? So that means now I can rewrite this as x squared plus 7x plus 5. That's my new quadratic. This is a quadratic function now. Okay, so I have 2, so I'm bringing this up here, okay? 2x squared plus 7x plus 5. Now I have to factor this. But I know how to factor this. This looks familiar. This looks like X game. So I'm going to multiply these two. What do I have on the top? I have a 10. This number goes on the bottom. Our linear coefficient goes on the bottom. When you multiply these two guys, you're going to get 10. Okay. So what two factors are going to multiply to 10 and add to 7? Oh. Well, it would give me 5 and a 2. But remember, this is X game. Because you multiplied by the 2, you have to divide out the 2. Well, what's 2 divided by 2 is just 1. I can't simplify this guy here. That's as simple as it gets. Okay, I can't simplify it. So when we write it in factored form, okay, this means this is our number, this is our x. This is our number, this is our x. So this would be here 2x. Now this is not a negative, so that means it's a positive 5. Same thing here. 1x, this is a positive 1, so plus 1. So these two are our factor form of this quadratic. Okay, now to solve, to find our roots, just set it equal to 0. So we have, by the 0 property, is this guy is equal to 0 or this guy is equal to 0. All right, so let's solve for x. Okay, there's one, and our other one is here. Yay, we found the other two roots.